In this problem, we have a car that's moving along at 7.6 meters per second. It has a mass of 1,141 kilos and it runs into a brick wall. The car comes to rest over 164.7 times 10 to the minus 3 seconds. So that's 164.7 milliseconds during the collision. That's how long it takes for it to come to rest. Question is, what is the acceleration of the car in G's? Well, first of all, we have our, we know, right, this is about change in momentum or the impulse, and the initial momentum of this car, well, the final momentum of this car is 0, right? And the initial momentum of this car is just mv. So we have the mass, we have the velocity, and so we know the change in momentum is minus mv. That's great. Now, we also know that the change in momentum is F times delta t. Well, we know delta t. We have a formula for delta p, and so we can solve for F. F is minus mv over delta t. Now, why am I looking for F? Well, I'm asked for acceleration. So if you put your way back hat on and go back just a couple of weeks into the class, you remember F equals ma. And so we're after the acceleration, which is F over m, which in this case is minus mv over delta t, right? And we're going to divide all that by m, which gives us another m down here in the denominator. And so what do we end up with? We end up with minus v over delta t. And so that's going to be the acceleration of the car, or the deceleration. Now here's where that's acceleration. Deceleration is minus the acceleration. So v over delta t. Now we have the deceleration of the car, and we want it in G's. And you remember, to convert to G's, we have to say, do the conversion factor, G divided by 9.81 meters per second. Typing is not working today. We go under meters per second squared. All right. So now we have everything we need. Turns out we didn't need the mass at all. Isn't that cute? So velocity, delta t, 9 and g, which is 9.81. Okay, our initial velocity, 7.61 meters per second squared. Our delta t, 164.7 times 10 to the minus 3. 9.81 is g. And so our acceleration, our deceleration, is going to be velocity divided by time. Let me put it this way. Divided by delta t times 9.81. So 4.71, don't have to change it. It's easy enough to read as is, but 4.71 Gs. Make sure that's all right. 4.71 Gs. And that's it for this problem. And all you're going to put into Canvas is the 4.71. There you go.